Hi friends, good morning. Today we are going to start with uh, lessons based on the Part A syllabus of UGC-CSIR net. As you know, this for UGC-CSIR net, Part A part that is common for physics, chemistry, mathematics and biological science, right? So, Part A consists of logic reasoning questions, right, and basic mathematical areas, and then graphical related knowledge, right, and then basic science questions from basic science, right, and a basic computer theory. From that and all we have questions, right. So today we are going to start with first basic mathematical area, right. So all the mathematical areas which we covered in lower classes, right, that is important. Okay, using that formulas and theoretical knowledge, tricky questions usually encountered in UGC-CSIR net examination, right. So all right, so let us start with today first chapter of basic mathematical science, that is plane figures, right. Plane figures, you know, quadrilateral, triangles, circles, right. So different plane figures we have. So we are starting with the plane figures. So let us go to the first plane figure, that is quadrilateral, right. Quadrilateral, a closed shape with, right, a closed four-sided figure, right, in which sum of all the angles should be 360 degree, right. So angle A plus angle B plus angle C plus angle D, right. What is that sum? 360 degree, right. So that is a quadrilateral. Sum of angle in a quadrilateral is what? 360 degree. So four-sided closed figure. All right. All right. So these all are easy for you, right. Next, parallelogram, right. What is a parallelogram? Parallelogram, a quadrilateral is a parallelogram if both pairs of opposite sides are parallel. See, these opposite sides are parallel, and the next parallel side this and this parallel. Opposite sides that are equal also, right, and this equal to this, right. Now the diagonals of the next point is the diagonals of the parallelogram divides it into two concurrent triangle, right. Look here. So this is the, so we have a parallelogram here. This is the diagonal of this parallelogram. Now you have two triangles here, right. One is triangle ABC, another is triangle ACD. See, this side is equal to this side, right. So this side is equal to this side, right. Now this is common, right. This is common for both. Now by triple S criterion, what you can say, these two triangles are concurrent, right. They are concurrent triangles, and a triangle ABC concurrent to triangle CDA. All right. So these are these. This is triangle 1. This is triangle 2. All right. Now in a parallelogram, opposite sides are equal. Already we seen this side is equal to this side is equal to this side, right. All right. The opposite angles of parallelogram are equal. Very important. See this angle. This is one angle. This is its opposite angle. This angle is, these angles are equal, right. Similarly, this pair, this angle is equal to this angle. This angle is equal to this angle, right. So two angles are below 90 degree, two angles are above 90 degree. But we add all the angles, angle A plus angle B plus angle C plus angle D, what? That is total sum is 360 degree, right. All right. Now, so opposite angles of parallelogram equal. Now the diagonals of the parallelogram bisect each other. Now see, this is one of the diagonal of this parallelogram. This is another parallelogram, another diagonal of this parallelogram. Now this length, this length, suppose this is A means this also A, because diagonals intersecting, so diagonal equally divide. Similarly, if this length is say B, then this length also B. That means by the intersection of diagonals, that particular diagonal divides into 2, that 2 parts are equal. Alright. Now so that about a parallelogram. Now see let us discuss about the area of this parallelogram, right? See, a quadrilateral is a parallelogram if one of the opposite side, one pair of opposite sides are equal and parallel. That we already seen. See, we have two pairs, right? One this pair, another is this pair. That sides are parallel and equal in length, right? Now perimeter of the parallelogram, but suppose this side they be given B, this side they given A, then A plus A, that is 2A, and B plus this also B, this also A, then 2B. So this is the perimeter. Perimeter means sum of all the sides, sum of the all the sides, right? Now what is area of the parallelogram, right? See, area of the parallelogram means we have already seen this is a parallelogram, right? Now here this height, say this is a parallelogram, right? Okay. Now suppose here I draw a diagonal, right? So what is this triangle area? Half into base into height, right? What is triangle area? This triangle area I am taking, half into base into height. Now this triangle area is equal to this triangle area. This is first triangle, this is second triangle, because they are concurrent. These two triangles are concurrent, we seen, right? Then 2 times, then 2 cancel, then B cross H, then base into height. Height you have to take like this only. Draw to find the height of a parallelogram. You draw a perpendicular to its base from one corner, from one top corner, right? From here you draw means you have to draw. This is the height, right? So height is the perpendicular length, right? So this is height H, right? All right. So base into height, right? Now area of the area of the parallelogram using side length, right? See look here, this triangle, okay, you consider. So this side A, this side say B, and the diagonal length is D. Now a triangle with 3 sides are different, then what we have studied? Triangle area, square root of S into S minus A into S minus B into S minus this is S minus D, right? This is what is S? S we defined as D plus B plus A by 2, right? All the sides you add, then what? A plus B plus D divided by 2. If define S like this, right? These 3 sides, that is sum divided by 2, that is S. Then what is area of the triangle? Area of first triangle is square root of S into S minus A into S minus B into S minus D, right? So we have 2 triangles like that, right? Then what is the area? 2 times square root of S into S minus A into S minus B into S minus D, right? All right. Now so this is about regarding area of the parallelogram. Now rectangle, right? What is rectangle? Rectangle means it is all the corner angle is 90 degree, right? This all the corner angle 90 degree, right? Moreover, opposite side, opposite pairs are equal, but it should be at a corner angle should be 90 degree, right? See, a parallelogram whose each angle is a right angle, then it is a rectangle. Parallelogram, all the angle A 90 degree, angle B 90 degree, angle C, angle D, everything is 90 degree, right? Perimeter, what is perimeter? If this is length, this is breadth, then this also L, this also B. Then total sum, right? Perimeter means total this sum, that means L plus L 2L, and here B plus B, that is 2B. So 2 into L plus B, right? So this is the perimeter of this rectangle, alright? Alright. Now area, what is length into breadth, right? Here also you have two triangles, say, see this is the one triangle. Then what is triangle area? Half into base is L, then L into, and height is B, right? If it is perpendicular means we can take this as height. Now similarly we have this is first triangle, this is second triangle. So into 2, that is the total area of the parallelogram. Then length into breadth. For a rectangle, what is the area? That is length into breadth. Alright. Now another point is the diagonals of a rectangle are of equal length. Right. See, in parallelogram what we have seen, this diagonal is more length, this diagonal is less length. Then D1, if say this is D2, D1 is less than D2. But for a rectangle, this diagonal and this diagonal what? This is both the diagonal, they are equal in length, right? Diagonals are equal in length. Now, if the diagonal of the quadrilateral are equal length, what we can say? It is a rectangle, right? In a parallelogram, if both the diagonals are equal in length, then you can say that is a rectangle, right? Alright. Now, diagonal length you can find it. See, using Pythagoras theorem, if this is L, this is B, using Pythagoras theorem, say this is a right angled triangle, what is diagonal length? Square root of L square plus B square, right? So, that is the diagonal length of a rectangle, alright? Alright. Now, what is a square, right? A square, that is a rectangle with a pair of adjacent sides are equal. That means a rectangle with all sides are equal, that is a square, right? So, let us see one figure. See, then what is a square? A square is a rectangle with all the sides are equal. This side A, this side A, this side A, this side A, right? So, a square is a rectangle with all sides are equal, right? Now, what is the perimeter? Sum A plus A plus A plus A, that is what? 4A, that is perimeter, that is A plus A plus A plus A. This is perimeter, right? Now, diagonal, see, so here again Pythagoras theorem. So, this side what? This is a right angle triangle, square root of A square plus A square, that is square root of 2A square, then A square root is A and root 2A. So, this is our diagonal length, right? Now, area what? Area is, right, area is equal to this triangle area what? Half into what is base A into height, that also A, right, A. Now, this kind of first triangle, two triangle, we have two triangles, then we can multiply with 2 to cancel, then A into A square, right? Then square area is what? Area is A square, right? Area is A square, alright? Alright. So, that is the square. And now, another property is, suppose you draw a square. So, let me take a pen. See, if you consider a square, right, all the sides A, right. Now, these diagonals bisect each other means, first of all, you think both diagonal, this is D1, this is D2, both the diagonals are equal. Now, next point is, for a square, these diagonals bisect each other means all the angle. This angle 90, this angle 90, this angle 90, this angle 90. Okay, so diagonals of the square are perpendicular. They are perpendicular to each other. All the angle 90 degree here, right? And that means this diagonal bisect also. This length is A, this length also A. This length also A, this length also A. That means these diagonals bisect each other, right? And it is diagonals are their angle between them is 90 degree, right? That means perpendicular. All right. Now trapezium, right? Next kind of plane figure, four-sided plane figure is trapezium, right? What is trapezium? So in parallelogram, two sides are parallel, right? Here same way two sides are parallel, right? But not equal. It should not be equal. See, a trapezium, suppose two side like this, right? But this side like this. So this is not a, this is a trapezium, right? Two pairs parallel, two pairs that is parallel, right? This side that are parallel, but not equal. They are not equal, right? Two sides parallel but not equal. But one pair should be parallel in a trapezium. But remaining other side should not be equal. That need not be parallel. That also parallel means it changes to trapezium. No, it changes to parallelogram or a rectangle. That is different case, right? Now this case, see, so a quadrilateral having exactly one pair of parallel sides called trapezium. Area of trapezium we can find, right? See, general expression is, see, half into, right, sum of parallel side. See, look here, this is one parallel side, say A, this is another parallel side, say its parallel side is B, then sum of parallel side what? A plus B into here height H, right? Height H, all right. So this, now this you can by considering, see, one trapezium you consider like this, right? Okay, now suppose you consider divided this into two triangle. Now this triangle, for both triangle height is common. If this you take as height here, right? So this height is common, all right? Now you can this half into A into H, half into A into H, right? Half into A into H, that is this triangle area, right? Now half into B into H, see this triangle, see, I am writing, so this triangle, see, triangle, this is ABC, so say this is parallel side A, this is parallel side B, then this triangle area what? Half into A into H plus, right? That is this triangle area. Now regarding this triangle, see, second triangle, what is the height? See, height is the perpendicular from opposite corner. So this is the height. Now this height is equal to this height, right? Understood? Then half into B into H, half into B into H. Now you can take half into H, you can take, what is remaining? A plus B, right? Then this formula, half into A plus B into H, that is half into sum of parallel side into height, right? So this all about a trapezium, right? Now this all about a trapezium, right? Now rhombus, what is a rhombus? Rhombus means in a parallelogram, say, think about a parallelogram. Think about a parallelogram. In a parallelogram, what you have seen, opposite sides, opposite pairs are equal. This is equal to this, right? But in a parallelogram, other opposite sides are also equal. But what we have seen, other opposite sides also parallel. See, so this also parallel, right? Equal, but all the sides equal. Okay, for parallelogram, this length should not be equal to this length. This is not equal to this is A, this is A, but this is B, this is B. But all the length should be A here, right? And angles are not 90 degree, right? Angles are not 90 degree, and over this thing, this in a rhombus, all sides should be equal, and corner all angles are different. That means angles are different means this opposite angles are equal. This angle, opposite angles are equal. And what is the different from all the sides should be equal. Here opposite pairs only equal, and this pair parallel, this pair, okay, these two pair parallel. So in a parallelogram, if all sides are equal and opposite pairs are parallel, then we can say it is a rhombus, right? A parallelogram having all sides equal called a rhombus. In a rhombus, the diagonals are perpendicular to each other. See, this angle all are perpendicular to each other. But in parallelogram it is not perpendicular. But in rectangle it is perpendicular. In a square it is a perpendicular, right? Here also in rhombus also diagonals are. Now area of rhombus, right? Area of rhombus is half into diagonal d1 into d2, right? Half into d1 into d2, right? This is the product of diagonal divided by 2. That is the area of the rhombus, right? Now each side of the rhombus means, you can calculate how. Each side of the rhombus means half into d1 square plus d2 square, right? See, to find C, look here, this is d1. Okay, here you can take this as d1 by 2, right? Now this you can take as d2 by 2. Okay, alright. So this side d1 by 2, because half the diagonally, this also half the diagonally. Now this angle is 90 degree, then this is hypotenuse. This I can take as d1 by 2 the whole square plus d2 by 2 the whole square. Then you can take 1 by 2 out, 1 by 2 square root of d1 square plus d2 square. That only this side, that is rhombus side length, right? So half into d1 square plus d2 square. That is the side length of a rhombus in terms of diagonals, right? d1 and d2, alright. Now next class we come to another plane figure, that is triangle, right? Once we study all the plane figures, then we comes to different kind of problem that are asked in previous net examination, right? UGC-CSIR net, and some exemplar problem also we worked out. Okay, thank you.